Hello, friend. Welcome again to another session of mathematics. Yeah, we're doing differentiation. So if you have just joined us, know that you have just missed part A of our solution. Now we're going to do part B, but you can watch the video for part A and put your comments there, see how we can help. So there we go again. There we go again. Here's the solution for part B. That's the solution for part B. Okay, we're supposed to find dy dx for this. Actually, it applies almost a concept similar to what we did in part A. Yeah, it has got some product rule in it. And it is implicit function as well. Okay. So the derivative with respect to x of x cubic sine y minus y squared unto x, this one is equal to the derivative with respect to x of 20x squared y squared. Okay, this is same as writing the derivative with respect to x of x cubic, then sine y, minus the derivative with respect to x of y squared tan 2x, which equals the derivative with respect to x of 20x squared y squared. So here we have to apply the product rule for these implicit functions, that if you are differentiating with respect to x a product of two functions such as u and v, this one is the same as writing v du dx then plus u dv dx. So for each of these terms, I will take the first function for u and the second function for v. So for this particular case here, I will write x cubic, then I will differentiate with respect to x sine y, then I will add to it sine y, and differentiate with respect to x, this x cubic, then minus, applying the same to this particular function here. Remember, we have put minus here. I would suggest that we put the square bracket. So we have y squared, then the derivative with respect to x of tan 2x, then plus to it tan 2x, then the derivative with respect to x of y squared, close our bracket like that. This one will be equal to our right hand side, where we have the constant here, which is 20. We can take that constant outside. So put there 20, then another square bracket, and differentiating that, we keep y, x constant, and we differentiate y. Yes, differentiate y with respect to x. Then the next one, we keep y constant, differentiate with respect to x, x squared. So this is what we have. So let's start with the first term here. Differentiating sine, that one gives us cos. So we shall have x cubic, then cos y. Okay, but since we're differentiating with respect to x, it will be cos y dy dx. Then here, differentiating x cubic, this will give us 3x squared, then sine y minus, okay, differentiating 2x, this will give us 2, differentiating tan, this will give us sec squared, then it will be 2x, then here again, oh sorry, this minus sign, let's maintain that bracket, this square bracket here. Okay, so that here we can add differentiating y squared, this will give us 2y, then it will be tan 2x. Okay, and 2x. Okay, close the bracket here. Okay, that's our left hand side. And our right hand side, we have the 20 outside there. Okay, let's retain its position, that is out. Here we have x squared, there we have that we're supposed to differentiate y squared. So this will give us 2y. So we shall have as product to be 2x squared, then y, dy dx. Okay, y, because we're differentiating with respect to x. Then add to it, differentiating this one gives us 2x times y squared. This is y squared, like that. Okay, this question has got so many terms, so we ought to be extremely careful. Otherwise, we're gonna mess up. Okay, you follow me, and you put your comments in case something went wrong, but I don't hope so. Okay.